Alright, welcome to my channel. I'm here to do my 100 Leetcode challenge. Today we have Leetcode 54, spiral metric. Given an m times n metric, return all elements of the metric in spiral order. Spiral order looks like this in this example, and we go around on the outside and then loop all the way to the middle to traverse all the number in this metric. In here, the same. You can go around, down, left, up, and keep doing that same order until you go to the end of the matrix. So in here, we will use a 4-pointer. So now we're pointing to this column 0 and column 2, index 2, and row 0, row index 2, and we go right first. After going right, the row will go down by 1. So now we have row 1 and row 2 to process. And here we have the column 2. We're going to do this column 2 by looping all the element in this column. So now we have row 1 and 2. So we put this 6 and 9 into the output array, our output list. And then after the second operation, and we're going to turn left. And we're going to do this after second operation, and then the row will -1. So now we have this 2 row only. So now at the third one operation, we'll have this square to do. We go left and then go up. After 4 operation, we have this left for the next operation. So you can see in the code now. In here, we will have an output of list of integer. We just type it out first. Array list. Oh, what's that? Array list. Okay. After that, yeah, we're gonna have 4 pointer like what we said. We have row, row star equal to 0, and row n equal to matrix dot length -1, and also have column star equal to 0 and column ends equal to matrix first dot length, first array dot length -1. Almost make a mistake here. So the condition is while the row s star less than or equal to row n and column star is less than or equal than column n. That's the condition of running this operation. So now we have the first operation of which is going to right side. For int I is equal to let's see, column star. We have column star all the way to column n. I is less than or equal to column n, then I plus plus. What we can do in here is output add matrix. In here, current row, which is row star, and we have I in different column. We add this integer inside that list that we have, and we loop through this whole row. And after this row is finished, and we can lower the row to next one, which is row star plus plus. So we already processed this row already. We can cancel out. Next operation is so now we are looking for this one. It will be row star all the way to I less than row n. Actually, you can have an equal here. So also getting the last one, I plus plus. So look through that, like from this row star to row n, including n, we can put those number matrix, and we add columns n. That's it for the second operation. So now when it's done, we lower the column n by 1. Minus, minus. And next one will be starting from column n, and we go counting backwards from 8 to 7. And we have i's bigger or equal than column star I minus minus. Okay, and output do the same thing, matrix. So now we have the row will be row n, and we got column is I. After that, we'll swing this down upward, swing the row down, row n, right? We move the row n upward by 1. And last, we have integer I is equal to, we are looping through the row. So we have row n to i's bigger than equal to row star, then it will work. Minus minus. The same thing here, matrix. We'll have, which is I. We got I. The column will be column star at the beginning in here. So now we have 4 operation. After that, we'll move column star forward to move it to here. Star to forward. So now we have full operation, which is for this operation, until we get to the number, and then at last we return the output. Here. Now it looks good, but why I went to a corner case, and you can see right here, it said wrong number when 1, 2, 3, 4, and 5, 6, 7, 8, all the way to 12, which is 3 row, 4 column. So we can imagine one of the corner case. So I can have an example by just loop to 1, 2, 3. So we have 0, 2, 0, and 0. So what is this? This is columns 0 and 2 here. I mean, I can first type out the solution. I think the problem here is if we need to double check as bigger than row E, or column S bigger than column E, then we'll break. Because you don't want to go further since one of the dimensions is already passed. Let me see. Okay. Go back to this example right here. So now we have 0, 2. This is the column, and row will have starting row is 0, ending row is 0 here. First operation, we look through this one from 0 to 2, and we get the row start. So that means 1, 2, 3 is done here. And later we see, what do we do? After this one, we have the starting row become 1. We add 1, like what we said. We will lower this boundary to the next one. After this, we will move this. So we'll go down from here because now we add here. We're going down from this point of right now. Since this way, I mean, the starting point of the row is already bigger than ending point of the row. So this one won't do anything, but it will put this, which is here, column N will be moving to here, which is 1 right now. After moving that, actually this is all already done, but without this condition, we won't break. And then we'll keep doing the later part, which is going backward, counting backward. So we'll put this 2 and 1 again to the output list. So we'll have extra stuff that we don't want for these cases. Same to the other case that just fell. Hopefully that is easy enough to understand. And I know it's kind of confusing, but it's good to always go through one line by yourself in this case, and you have better understanding what's happening. Let's erase all the drawing first. And now go back to the code, run the code, find, submit the code. Now it passed. So see, I make a lot of mistake also just because of this condition. So it took me a while too. So feel free to ask me any question or comment it below, and I will see you in the next video. Bye.